To start out for you guys, welcome. Thank you for joining us today. My name is Dakota Baird. I'm the product manager for tube, bend, and import and export here at Sigmatek. So I deal a lot with getting customer parts into our software and then a lot with some more of our 3D focused products like the bending and the tubing. Of course, if you guys have any questions over anything that we'll be going over here today, feel free to add those into the chat and we will answer those here at the end of the presentation. So to start out, I just wanted to go over a few of the common problems that we're going to be solving with the tools of our software today. So the first one being just general effort of tool changing not being factored into the quoting process. So a lot of these shops are able to kind of estimate how long a particular part's going to bend, or they're quoting just on the number of bends on a particular part, but they're not really factoring in how long it's going to take to do the setup for that machine for that particular part, or even changing the setup between parts. So we want to help alleviate some of that and reduce that time. And then the second is going to be some more complex bend sequencings or bend setups leading to misplaced tools or stress on the operator, right? So if we've got some more complex parts, we tend to see a lot more setup configurations between programs. We're having to continually add and remove tools to the break, and that can lead to misplacing those tools. And then, of course, just general wear and tear on your operator through the physical labor of doing all of that tool changing. So what we're going to do is show you today two advantages that you'll get from using SigmaBEND to program your brakes. So the first one is being able to utilize a single station setup for multiple programs. So this is key to reducing that operator, manual labor time of actually having to remove any tools at all from the press brake machine. And then the second one we'll go over for you guys is optimizing the sequence between part programs to reduce the tool changing. So to start out here, we'll go over the feature within the software. I'll give you a brief demonstration of how it works, how to set it up, and then we'll talk about some of the benefits that brings you. So first one, like I mentioned, is saving and reusing station setups within the software so that multiple parts can utilize the exact same setup on the machine. So here in the software, I'm going to go to my machine library and just open up my machine settings. So the one thing I'm going to do here is configure my machine as if I'm a bit of a smaller shop. So I don't have a lot of different varying profiles. Or for example, we know that we like to bend with very common tooling. So I'm coming in here and setting up what we call preferred tooling. So for a particular material or thickness, you can specify to the software to try a tool punch and die combination first. You can even give it multiple combinations. So if you want to try one punch and die combination first, and then if that doesn't work, try another set of combination, you can set that up here. So I'm just setting that up so that I'm mimicking a smaller shop with less robust tool library. So we've got a pretty complex part in here first. So some common line bending, some internal bends there that are going to require a smaller station. I'm just allowing the software to program like normal. So generating our flat pattern, allowing it to solve for the best sequence, the things that are going to minimize within the program itself, station changing, back gauge movements, flips and turns, all of that. And then we're going to just do a station setup. So for this particular first part, we're going to allow the software to solve for its own station setup. It'll come up with two stations here for this part, one larger station for all of the larger bends and one smaller station for that internal bend there to avoid any collisions. I'm going to play through the simulation as if I was normally programming this part. Just checking for collision, checking for any interference, making sure the movement looks okay. Assuming everything looks great, I would pulse this program out to the machine. This is the station setup that operator would see on his report file, and he would set up this station for this part. So what I'm going to do is go back into my machine setup and head over to the tooling tab. And I'm going to save this setup as a managed station in the software. So essentially, I'm telling the software this is a station that's already set up on the machine, and I want to potentially reuse it for additional parts that I'll be programming today. So I've got that station saved in my machine. I'll go ahead and open another part for programming. This time, maybe we'll look at a very simple part, something that's only got a couple of bends, not very complex. I know that based off of the geometry of this part, it's pretty similar lengthwise on the bends to the previous part I was programming. So I want to step through the process again with the software, generate my flat pattern, allow it to solve for a sequence, this time obviously 2 bends much faster. And when I get to the set of the in the process where I'm setting the tool station, I have a new button here, so I can open this and see previously saved station setups. So I'm going to tell the software select this previous setup and see if this part can fit on the stations already. So it's gone through, analyzed the bends that were already on the part and the station I've told it to use, and just making sure that everything can work. Everything looks good. I now, without changing any tooling, can perform both of these parts using the one setup. So again, just continuing through my day, we'll do a third part just to keep the process going. This one maybe a little bit more complex, but still pretty simple. I'm just throwing in a collinear bin there now. Again, generating the flat pattern. We're going to solve for the proper sequence. And then again, when we get to the tool station setup portion, I'm going to tell it to reuse that existing station. And it solves, even for collinear bends, which station it needs to use, where the part needs to be in the existing station to avoid collisions. So you can see kind of moving off to the side of that station so that it doesn't have any issue with the flanges. So good to go again on the third part. Now my operator can perform all of these these parts with the same tooling setup. No tool station changing required. So when we look at this type of feature, this is really most applicable to customers with lots of similar parts. So obviously you need to be reusing the same tooling in order to do this. So if you have lots of parts with similar bend radii or similar features, this station optimization tool is a lot more beneficial or applicable to you. It can save you a lot more time. It's also more applicable to people with lower tool variety, right? So if I am programming a lot of parts that I know are gonna require different profile tooling to change in between them, it's not really going to save me much time here because those additional parts are not going to fit on the existing station. So we like to see this with customers with lower tool varieties. And then obviously, like I was mentioning in the beginning there, customers with preferred tooling preferences. It's very helpful for them because they tend to use the same tools over and over again. As far as the benefits here, we're obviously seeing any unnecessary station setup changes. So what we like to say about this is essentially if those 3 parts were programmed in the software individually, you'd end up, even though they use the exact same tooling, with 3 different station setups, right? Because it's going to try to find the segments in your library that match the bend lengths as close as possible. So even with those 3 parts, you're going to see different station setups without this feature, and that leads to the operator having to add and remove different segments from the machine that are completely unnecessary, right? Because we just saw those 2 extra parts could be performed on that first station setup. And in turn with that, obviously it's reducing the operator's manual labor. He's not actually having to do that process at all, so he's only having to worry about bending the parts. And then obviously reducing the risk of misplacing those tools like we talked about in the beginning. If I'm not constantly taking tools on and off the machine, I don't have to worry about misplacing those because I needed to reuse those for a part, 2 programs down the line. I can make sure that that tooling changing is never even happening and completely removing that risk. Right, so the second feature we've got for you guys today is showing you how we can optimize the sequence of bending your parts. So we're going to use our batch and remote tool here, which is our automated programming. So I'm going to jump into that and kind of talk over the automation that's going on here. So this tool is essentially performing the programming for you without having manual intervention. So you're just giving it a set of parts here. It's going to load those in. I'm going to specify, what material these parts are, what machine I want to perform each part on. We're going to assume for today this is a single job that I need to get done in this shift. I'm going to perform them all on the same press brake machine, but then I'm going to go in here and specify some quantities. So I may have more of a certain part that needs to be performed for the job. And then I'm even going to set some priorities here. So this particular part, I'm going to tell for the shift we need 50 of them, but these are filler parts. We're just going to stock these on the floor, and when someone orders it, we'll just pull it out. So I've got a couple of parts here that I've set to filler, and then I'm coming back here and specifying that 2 of these parts for these jobs, this job needs to be a rush job, right? So these first 2 parts I need to program first on my machine. No matter what, they have to go out the door ASAP. So letting the software know that, it's going to go through and do the automated programming. I'm going to speed up this part a little bit so that it can get through all of these parts. Once that's finished, we're going to go into our Produce tab here, and this is essentially our queue optimizer. So it's going to analyze the tooling that was selected for each of these parts, their quantities, their priority, and come up with the best order to perform the programs in. So my queue summary's got at the top here all of the tools that are going to be needed for this particular job of parts, and then in sequence what order to bend those in. So it's going to analyze what tooling is used on a particular part, and then what's the next part I can program that requires me to change the tooling the least, whether that be station setup or individual profiles are changing. And it also kind of has to analyze that rush job, right? So if I had one or 2 parts that needed to be a rush and the tools had to change between them, it knows that. It's going to allow you to still do that. But then for that third part that may not be a rush job, it's going to check that tooling change optimization. So if we take a closer look at this report file here, at the top you can see the name of the job or the batch, what machine they're being performed on, and the day. But you can see that we've provided you a setup improvement. So this percentage is going to be based off of the order you told the parts to program in when you were adding them. So by default, if you hadn't done any optimization, it was just going to go down one by one, and that was your tool changing, right? You'd run the first part, then the second part, then the third, whether or not you were looking at priority or quantity, nothing at all. But with the queue optimizer, we've gone ahead and saved 9% of setup time here just by resequencing the parts. We didn't do anything with station reuse or anything, just order of part bending saved 9% here on our setup time. So if we analyze these particular 13 products that we had, the various different quantities, and the estimations on the bending time and setup time, we were looking at about an hour to program this entire job from the time estimates. On a per part level, that was about 30 seconds per part based off of the quantities that we had. In a normal kind of standard environment, we can estimate that manual clamping of tool changing and things like that is about 10 minutes for a program. So an operator's got to go find the tools. He's got to load them in the station. He may have to remove the previous station. So about on average, we're estimating 10 minutes for a program for the manual clamp of the tools. So if we save 9% there, that's about 12 minutes of just tool changing that was completely saved. If we look at that across the entire job and maybe a shift and kind of extending that out over an entire shift for an operator, 12 minutes is equal to about 24 more parts per hour, which is equating to about 140 more parts per shift. So just by letting the software kind of optimize the order we're bending parts in, we can estimate that we can perform 140 more parts that day and get 140 more parts done. So you can see how that can quickly lead to a lot more throughput for production. There's also a little QR code on these reports so you can kind of scan and it'll pull up the individual bending programs for each of the parts there, so you can see their individual reports. It's not just one large queue summary there. So those are what the QR codes are for on the report there. So if we look at where is this most applicable, right? So this is quite a bit different than that first feature where we're trying to reuse the setup that's already on the machine. So this is a lot more beneficial for people with larger volumes of parts, right? A job shop that's coming through thousands of parts a day that they're having to bend, maybe even across different various machines. They've got a lot more unique tooling, a lot more unique parts and geometries that are requiring tool changes. Their daily production runs are heavily varied, so they can't really use that first tool very well. Because they have to change the setup. So in order to help them out, we can reduce at least the time it takes to do the station changes by reducing by optimizing the order to program them in, right? So it's obviously, like we talked about, increasing the production output. We saw 140 more parts in a shift. We're reducing manual labor on the operator still. It may not be as much as that first feature because he is having to do tool changes, but he's having to do less tool changes, and it's a lot more organized, right? We're trying to keep the tools that were already on the machine still there and just do removal of the necessary tools and maybe adding a few more stations for a particular bend that may have changed. So there is a reduction still there on the manual labor side, and then because it's more structured and organized, and we're controlling a better sequence to remove and add tooling there, we are still reducing the risk of misplacing any tooling, right? Because we're trying to avoid you taking tools off the machine and then having to put them back on the machine. So if you can trust that the sequence was able to optimize very well, you can trust that you're just taking things off the machine and you can put them where they need to go instead of taking them off and storing them for a part that comes up 2 programs later to put it back on the machine. So still reducing the risk of that misplaced tooling there. All right, so with that, I think that's all we had on the software demonstration side, but we definitely wanted to open it up for questions here. So I think we'll go ahead and jump into those. So the first question I've got here says, can we see the drawing of the program for mixed parts? I assume that's for the batch run process at the end. And if by drawings you mean like flat patterns, we definitely, that automation tool, what it's doing is doing the whole programming process. So you'd set it up to import the part, generate the flat pattern, create the press break program, and also generate the bending report for the part as well. So you'd get all 3 of those files, the flat pattern, the bend report, and the NC for the machine. Hopefully that answers that question. If not, if you can elaborate a bit more, I can try and answer it a bit better. The second question we got here from Chris says, can the software import SolidWorks part files or only step? The software absolutely can import models from all the various different CADs, SolidWorks, Inventor, Creo, Solid Edge, NX, not just step files. Right. Next question here was, can we see a graph of the tool positions on the machine? So what we offer for this is on the individual bend program reports, there is a generalized station image that you get to see where the particular tools are on the setup, and then it has the X location on the rail for each of the segments. So your individual bend report for the individual part itself has that station setup information. The next question there was, can you send programs to all press break brands? So we definitely have a library of machines that are supported. Generally, on the press break side, it's more concerning to the controller rather than the brand itself. We tend to see some manufacturers mix and match different controllers based off of the model that they're using. We have a full library of machines that you can get with your salesman with, and he'll validate that the machine is programmable. For the most part, we run most every press break machine with some small caveats for the brands that like to lock things down a bit more. And then the next question, more of a generalized software question, who will create and import the tables of bend deduction and bend allowance? So that's something when you purchase the software that our support engineer that comes on site for your training and machine setup is going to walk you through. So there's definitely material tables that need to get set up before you start programming. But our AEs that come on site to do your training are going to help you along with that. It may even involve some coupon testing if necessary, if you have different qualities of mild steel that you have to set up that have various different slight K factor differences that you need to denote down. They'll go through that process with you as well. And it's definitely something that's important to the initial setup during the training. The next question we got here, is it possible to import assemblies from SOLIDWORKS? Yes, it is. We didn't really go over the assembly import feature here, but both the manual programming method can import assembly files, and then you can select which parts from the assembly that you'd like to program. And the automation tool as well. The automation tool requires a bit more setup, right? Because it's having to go through almost the entire assembly and find which parts are press brake programmable. So for that, we usually prefer that you set up some type of filtering within the software, some CAD property or file extension type. For example, on the solid edge side, you have normal solid edge parts, but then your sheet metal parts that people are typically designing for press brake machines have a separate extension. So you can set up assembly filtering rules to make sure that the automation tool is only picking out the parts that are applicable for press brake programming. The next question here asked specifically about a controller, the Amada M2. The only Amada control that's currently supported with the software is the older operator controls. A lot of the newer Amada controllers are pretty locked down, and just Amada is capable of programming those with their own software. Next question, does it show tonnage used, K factors for thicknesses on the reports? I'd have to check on the report file, but absolutely tonnage is factored into the tooling selection for the machines itself. So we have tonnage values that you're setting on your tooling, and it is doing calculation for you while programming and selecting the tools from the library of which are applicable for the part based on tonnage. So it is a factor. I would just have to check to be 100% certain it's on the report or not. Next question here was about some issues they're having with DXF files unless it comes from Sigmatek. Any fix for this? I'd have to see the files particularly if there was a case number that you could provide. An application engineer can reach out to me and I can sit with them and look at the part individually. But yeah, I'd need to see the parts specifically to go over that one. The last one here, is it possible to import custom tools? Absolutely. So the software by default comes with a lot of the major tooling brand catalogs pre-populated. And there is even a standard shape tool creator if you don't have the DXFs, but for custom tooling, as long as you have the DXF file, you can import that and make a tool out of it. The next question here, if we get a flat pattern DXF file to burn the part, uh, does the same file work for the press brake? So I assume this is asking if you have just the DXF or already have the flat pattern for the press brake part that you're cutting on your laser machine or using in a different software for cutting. Can you use that flat pattern DXF file as the import into the software? Yes, you can. So it can import a DXF, but it is a bit of a manual process, right? So it'll bring you to a bit of a different dialogue. It needs you to let it know which are the bend lines on this file, what are the angles, what particular K factor do you want to use for this bend. Are there lines on this DXF that include the bend region and not just the bend line, so that we can make sure we're filtering that stuff out? Which lines in the DXF are actual cutting contours, so we know how to essentially redraw the part for you in 3D, so that we can then continue on with the programming process. But you can use DXFs as a starting point. Right. Next question here. Can SigmaBEND be automatically fired up when you make auto task in quote to check if the product can be bend on my machine and produce costs of it? So we don't have anything at the moment for triggering an automation like that to let you know if it can be possible. You can obviously give that batch and remote tool a file, and it will spit back an error log. So if it's particular part that either can't be bend because of geometry, or you gave it a part that doesn't have any bends on it, you'll get an error message back. If you give it a part that is impossible to bend with your tooling library, so it wasn't able to find any valid tools for your machine or the part, you'll also get an error message back. So that batch and remote tool has two things. For the actual programming, but then for parts that it can't program, it will let you know that. You have the option even of manually opening that part and maybe okaying a few of the errors. So maybe some of the errors weren't as large. You know, it's a very thin sheet metal part that has step bending, and we found a collision with the machine, but you know, because it's very thin, that's okay. You can manually open that and still post the program out. But for those parts that physically can't be bent on your machine, you'll definitely get an error log. It'll tell you why. So it'll say no tooling found for this particular part. It may say no flat pattern, or the geometry couldn't be used to create a flat pattern. So you'll get information about that. We just don't have anything that can automatically fire that and then spit back that error log to your system. But you could definitely kind of set up some tools to try and help you do it, just nothing automatic yet. Right. Next question we got here says, for the process of cutting, we have to make the right flat pattern from the bending software. Um, how can we be sure the flat part is correct from the very beginning? So that is the basis of why people do offline press break programming in general, right? Is because you can't just get an accurate flat from having just the model and even using just K factors, right? Because if your particular tooling isn't perfect to create that radius with that exact bend region to create the finished part, even your flat pattern without tooling selection is not going to be correct, like you're mentioning, and you need to make sure that's correct. So uh, just offline press break programming in general is why we like to do that, because the tooling can change the part, and the software does change the flat pattern as you're going through the tooling process. So that flat pattern that I was saying initially that it was creating is just kind of the starting off point. When it actually selects the tools, it'll check with the punch and die combination, as long as it was within your tolerances for selection, what's the new resulting radius, and change the flat pattern to be correct for that tooling. So as long as you're having that all set up in the software, and as long as your operator is actually using the tooling that the program is asking for, you can ensure that that flat pattern that's being used for the cutting process is going to be correct. So then there was a question about the time saving and the formula. It was just a very basic kind of estimate there. So I was looking at just some shop floor data from various customers of how long it takes to do station changes for manual clamping. There's of course machines out there that do auto tool changing or indexing and have automatic clamping that can do it much faster. So I used a manual clamping as the baseline, and saw that the average for that was around 10 minutes for a program to do the tool changing side. So that factored in, you know, setup, tear down, finding the tools, that kind of thing, and just use that for the calculation there. So I was strictly looking at the bending process too. So another piece of that question was asking about the burning and the drilling. So I wasn't looking at any of the savings on the cutting or after bend process savings. That was strictly just for the press break itself. Right. Another question here to add the flat pattern, add to the flat pattern question. This person does a lot of work where they don't control the 3D, but have to work in reverse from the flat pattern. So that's where that DXF import capability comes into play, right? If we can use the DXF as a starting point, recreate the 3D model for you, and then from there, we're doing the unfolding tool assignment, updating the flat, and you're going to get a new flat pattern out of the software. So even in that particular case, right, you don't want to cut the flat pattern that you already have. You want to bring it into the software, have us generate the 3D for you, do the press break programming, update the flat pattern based off of the tooling selection, and then give you a new flat pattern to cut. There's a bit of a clarification question on the calculation for the flattening. There's different settings within the software, so there are various different options for how it's doing the material calculation. So you can choose. So that's something that you'd get to set up and configure during the training with the AE when they're on site for you. Sorry. So the question, does it update the flat pattern for the part to be cut? I.e., does it feed back to that after seeing what the bend will do to the flat that is? So the only data we have to update the flat is whatever is within the software. If there's things that happen on the machine side itself, so even with the tooling selection in the program, if something on the machine requires you to do a different calculation. Things like spring back and that kind of stuff can be calculated in on the software side. So we can account for that. So, either overbending or underbending to give you the right dimensions, that can be configured in the software. But if there's something else outside of the software that's going to affect it, we can't know about that to update the flat pattern. But the actual programming of itself, the tool selection, that all is factored in. So there was a clarification question about a way in SigmaNest to get the time study. If this pertains to like actual production times and feeding that back into the software, for the press break software, no, there's nothing to feed back into it. It is a bit of a manual kind of time estimation set up on the software side. So you're saying for particular material and thicknesses and weights, you're estimating how long it takes for an operator to pick up, set down a part of that size and weight. You're estimating how long it takes for that operator to put things on and off the machine, and it's using that estimation for its time savings. There's some things that our offices have done with various feedback tools and mining informations from the machines that are capable. We just had a tech summit last week here, and our Italy office was sharing some things that they've done on the press break side with Industry 4.0 in terms of getting the actual bending data out of the machine from a particular program run and recording that. We have some shop floor tools to record actual production times for bending as well, so it's more of a start-stop kind of record. And maybe that initial bending time was used for the quoting process, but you want to have some analytic data on the actual production time and compare it to your quote so you can start to estimate better. That tool can start to record that information for you per program and compare them and tell you, you're usually 10% off on all your programs you've been posting or estimating. So maybe you tell your estimators to add an extra 10%. So I don't have any information yet for anybody in terms of what machines were compatible with that Industry 4.0 tool that I was talking about. Something very new that our Italy team has been working with. It's specifically important in Italy because of governmental kickbacks and things on taxes for the Industry 4.0 stuff. So a lot of manufacturers in Italy and people selling in Italy have allowed for it. So I don't have that list yet. They're kind of working with us. That was part of our, get together last week with our global teams, was to start to collaborate more on the types of custom tools that they're developing. So once we have that information, we'll absolutely be posting knowledge base articles and sharing it on customers, or even doing future webinars to share that type of information. All right, and I think with that, then we'll go ahead and end the webinar. And again, thank you guys. Any sales questions, pricing related stuff, reach out to your local salesmen.